Until now, the Qualstar 1269 track tape drive was driven by a PerTech card in a Windows 98 machine through this 62-pin D shell cable connector. We're now going to describe how to interface this drive to an Arduino board. I built an interface board to connect the 62-pin D shell connector from the Qualstar tape drive to more convenient dual inline pin connectors that with wire jumpers can be connected to the Arduino I/O ports. So the board has been wire wrapped, and I've got a heavy ground connection. And basically these documents here outline what the functions are of the 62 pins on the Qualstar PerTech pinout. And it's divided into output functions and input functions, such as writing data would be an input function and reading data would be an output function. There's strobe lines to deal with, timing, and tape control signals, as well as status signals. So I grouped them accordingly on these connectors. So the read-write data is on this connector A, the tape control and timing and strobes are on connector B, and then C have some auxiliary commands such as tape rewind, tape unload, and the status such as the density and if the unit is online, etc. So there it is. This now enables us to connect the Qualstar tape drive to the Arduino board. I also drew out a summary sheet of the pinouts on each of these connectors. So A, these are the pin numbers and their functions. And same for the B connector. And same for the C connector. We have a tape currently mounted, and the interface is now connected to my board. And we're going to do a brief test, something very simple, just to see if this thing is working. So on connector C, pin 1, where this orange wire is connected, is the unload command, tape unload. So if I briefly ground this wire onto pin 14, which is ground, this one here, there we go. The tape is unloading. It worked. So this is the beginning of our interface connections, and we're now ready for the Arduino board and to write code. Now, one of the issues that will have to be addressed in the Arduino board is how fast can it process instructions. When the tape is operating, it's running at 50 inches per second. The density of the data is 1600 bytes per inch. So that's 80,000 bytes per second. That means 12.5 microseconds per byte. Now there are strobe pulses generated by the tape drive telling the program that's reading the data that following this strobe pulse is the time to extract the 8 bits of data, if you're reading, for example. So you've got about 12 microseconds in which to do this reading and also logic to see if there's a next strobe or if you've reached an interblock gap. So that's quite a few instructions, 20 or 30 instructions. The question is, can they be accomplished in 12? This will also necessitate reading the data on a parallel port. So the I/O pins on the Arduino board will have to be 8 pins will have to be a port read or write rather than a single pin, because all the 8 bits have to be extracted at once. To do this right, an interrupt will have to be set on the Arduino board every time there's a strobe pulse received. When the I-go line goes high, the command is given to start the tape mechanism. When the data busy line goes low, the tape has reached its operating speed, and this is from this point on, the strobe pulses will be generated. When you reach an interblock gap, which is 12,000 microseconds long, you have this time between when the busy line goes high and for re-instructing if you want to continue reading the tape for streaming purposes or if you want to stop. It'll be overridden if the go signal is high.